So, good morning, students. Do everybody is able to hear me? Am I audible? Do everybody is able to hear my voice? Am I audible? Just tell me in the chat box, please, quickly. We'll just get started, students. We'll get started with. Okay, fine. So, I think, we'll just get started with, uh, you know, um, yes. So, good morning, everyone. So, I think yesterday we stopped with what yesterday, right? So, the previous class, actually, we were just stopping with. So probably we'll just start with divide and conquer strategy as and also the problem of merge sorting. Okay, we'll just go with merge sort. Okay, so merge sort is what we're going to see, and it's completely going to be divide and conquer strategy. Okay, so based on divide and conquer strategy, let us go with merge sort. So before getting into merge sort, we need to understand operation called as merging. Okay, operation called as merging. Okay, so before that, just 1 minute. Okay. So hope there is no noise now. Okay. So let us just like go ahead with the divide and conquer strategy and merge sorting. So before that, we need to understand one array operation called as merging. Merging is a very important operation where two sorted arrays will be taken as an input. Two sorted arrays will be taken as an input, and we will merge both of them. And the resultant array that we are creating out of it also has to be sorted. So two sorted arrays are taken, merged, and the resultant we are getting a single array, and that single array also will be like completely in sorted order. Okay, so first of all, let us understand this merging process. It's a very simple process, but let us understand the merging process first of all. So for understanding merging process, let us take two different arrays. So let me take the first array of size, like I'll take 1, 2, 3, 4, and 5. And also let me take one more array. 1, 2, 3, 4, 5, and then 6. So one array is going to be of size 5 and the other array is of size 6. So if I have to merge both of them and I have to create a single array, and that what should be the size of that single array? The size of the single array should be size of first array plus size of second array. 5 plus 6, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11. Okay, so now coming here, this is 0th index, here 1th index, here it is 2nd index, here it is 3rd index, and here it is 4th index. And coming to second array, it is 0th index, 1st index, 2nd index, 3rd index, 4th index, and then 5th index. And coming here to this array, let me take it as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now coming here, I will just take this array to be array left array, and let me take this to be right array. Okay, and this final array, let me take it as merged. Okay, MERGED, merged. Array name is itself merged. So here what we have done is we have taken two arrays, left array, right array, and also resultant array called as merged, so that if the left array and right array is merged together, like 5 plus 6 elements, totally we will require 11 elements. So we are taking the size of merged array to be 11. Okay. Now let me fill this array left and right, but both have to be in sorted order. That's the first constraint. That arrays that we are trying to merge has to be both in sorted order. So let me take here 10, 15, then 26, then 31, and then 45. And coming here, it is 7, and then 16, then 33, then 38, 46, and 48. So this is the set of elements that I have taken. Both are in sorted order. Okay, both the array is in sorted order. Okay, so what is the, first of all, what is that we need to be taking? We are taking two arrays, and the process name, the operation, like the name of the operation is merging. Okay. Just 1 minute. Okay. So now what I will be doing is I'll be taking variable I, zeroth index of left array, I will point it with I variable. Zeroth index of right array, I will point it with variable j. Okay, so I is equal to 0 for left array, j is equal to 0 for second array, which is right array. Okay. Okay, so we are just taking two variables I and j, where I is pointing to 0th index of left array and j is pointing to 0th index of right array. Okay, so now I'll just take ith index of left and jth index of right element. Okay, jth index of right array, and we will compare both these things. Ith index of which is left of I. I'll just write it here, which is left of I. We will be taking left of I and we will be comparing it with right of j. We will take left of I as well as we will be taking right of j, and we will take this left of I and right of j and we have to compare.
Excuse me, sir.
So now, as I said, I'll be taking left of I and right of j and I'll be comparing. Now, what is I? 0. So left of 0 and right of 0, presently I will be comparing. When I take left of 0, right of 0, and I'm comparing, two things can happen. Either left will be greater than or equal to, less than or equal to right, or other possibilities, right can be less than or equal to left, or left of I will be lesser or right of I will be lesser, or both can be equal. Those are the possibilities, right? I need to find minimum in both. If both is equal, I can take any number, no issues. But if which one is minimum, what I need to pick here. So I will check whether left of I is less than right of j. If left of I is less than right of j, then I will left of I be the minimum element. And if this condition is false, I will take right of j to be the minimum element. So if left of I is less than right of j, this condition is true. I just simply go left of I, just left of 0, which is 10. I'll take that value and I will place it, and also I will take a variable called as k, which will be pointing to the 0 index, where 0 index of merged array. So whichever is the minimum value, I will take the minimum left of I or right of j, I will pitch it. I'll take it and I'll store it in k index of merged array. So which one is minimum here? Between left of I and right of j, 10 or 7 is minimum, which is right of j is minimum. So when the right of j is minimum, I have to take the 7, right of 0, 0, 7, I will be placing it in the index of merged. Once you place it in k index of merged, you move your k index. Because the next element coming in have to store in the next. So k is represented by 1 does first. And in right array, I will also take my j 1 and I'll push my j 1 because already 0 have been taken into account. I don't want to repeat that. So that's over. Let me move my j to the next and let me go with the next. Okay, 7 is over. Now again let me compare left of I right of j. Now left of I is left of 0. I is still 0, but j has become 1. So I need to take left of 0 and right of 1 and I need to compare. Okay, left of 0, right of which is minimum. Left of 0 is 10. Okay, left of 0 is 10 here. And right of 1 is 16 here. Which one is minimum? 10 is minimum. So take which one is left of I is minimum. So take the minimum value and place it in the index merge what is K in the index 1. So take value and place it in the K index of merge. Once you place it, what is the next step? You need to implement K by 1 first step. Next step is if you are taking right of J, you implement by J. If you are taking left of I, then you implement I by 1. So now we have the left of I, so we need to increment I by 1. So my I will be equal to 1. Now again, left of I plus right of again in comparison. Left of I minus left of 115 and right of 116. Which one is minimum? Left of I 15 is minimum. Left of I 15 is minimum. So let's take the left of I place it in present K index 15 I place here. And then let me increment my A by 1. So K will move to third index. K will move to third index. Then I took left of I, right? So if I have taken left of I, then I increment my I by 1. So my I will reach second index. Now again, let me compare left of I and right of J. I think between left of I and left of J, right of J, right of J is minimum, which is 16. Right of J 16 is minimum. So I take 16 and I place it in the index of merge. And once that's over, I have to increment my K by 1. So my K will now reach in the index. And which one I just took here? What was the element I just which J index element I took? So my I will my J, because I can take right of my J will be multiplied by 1, my J will be here. Now take again left of second index, which is 26, right of 2, which is 33. So now which is minimum? Now which is minimum? 26 is minimum. Left of 5 is minimum. Take the 26 place in K in the index of merge and increment K by 1. So K will reach fifth index. K will reach fifth index. Okay. So then after K reaches fifth index, what is the next thing? So we have to also increment I by 1 because we have taken I like last time I left of right. So I am incrementing I by 1. Now take left of I and right of J. 31, 30. Which one is minimum? 31 is which is I then left of I. I'll take that and I'll place in K index of merge array. And I'll be also incrementing the respective like in variable by 1 which is K. And also I will increment my I by 1 because I have taken left of I. So now I is pointing this particular fourth index. Now just take this and compare. Okay, I index 45 and J index 33. Which one is minimum now? 33 is minimum. Take right of J 33, place it in K index of merge and increment your K by 1. And after that, then you increment your J by 1 because you have right of J. So I will just simply increment J by 1. Now take J index right and left of I and compare. Left of I is 45, right of J 38 is the minimum. Let me cut the 38 and place it in K index over here. Okay. And then the next thing is let me implement my J by 1 because I have taken the J index. So my J will now pointing to 46. So now let me compare I index 45 and J index 46 where I index 45 is lesser. So I take lesser value 45 and I place it in the K index. We got to implement the K value also. So K value here in 8 index. So 45 will be placed here. And once I place it, my K will be like it will be moved to next index incremented, and my I will be incremented because I was having the I element, I will be incremented. So my I has reached out of the array, has gone out of the array. So which I say that the left array has completely all the elements of the array has been taken for the merging process already. So here there is no I and J to compare. No left I right J to compare here. So suppose the left array is getting completed. What you do is copy the remaining elements of right array and just take it merge array. Suppose the right array is completed and left array is still there. Copy the remaining elements and get into merged array. So now where is the K index? It is in fourth index. So after fourth index, whatever value is available in the right array, copy everything directly to merge. You don't need a comparison because nothing is available to compare. So J is what you want to have 46. 46 increase the present k index value and increment your k as well as increment your j by 1. So your j will reach fourth index, fifth index. So after copy that index also 48 ppl and place it in present k. After placing it, I will remove the I and j by 1. So j will reach outside the array, a will also outside the array. So when A reaches outside the array, when A reaches outside the array, you can say the second array, right array is also done, completed. So when both arrays completed, now you can merge the array, they are completely sorted and all the elements of both the arrays are available in this merged array. 7, 10, 15, 16, 26, 31, 33, 38, 45, 46, 48. Okay, elements from both arrays are available and that is completely in sorted order. Completely is in sorted order. Okay. So this is the process. Once again, let me tell you. Once again, I will just tell you from first. People who is working in English for the very first time. Okay. So let me fill the head once again, make it completely clear, and then we will like see further the merge sort concept. Okay. So let me just take all this thing. Let's start completely fresh once again, and let me tell you how a little faster. Okay. We'll go a little faster. Right. Coming to a merge engine. Merge engine is a operation which is performed on two sorted arrays. It is the operation can be performed between two sorted arrays. That's first thing. Technically, two arrays like one is left array, other one is right array, and both have different size. That's not the issue. But both the array have to be sorted out. Okay. It depends. See, when you take two ascending order sorting arrays, you can merge both of them together, and you can create a new array which is also in ascending order. Suppose you are taking two ascending ordered arrays, and when you merge it, you can expect a descending ordered merged array. Okay. So sorting depends on like what order of sorting is there. One is increasing order, the other one is decreasing order. Suppose that two arrays, it's not like the array is increasing, right array is decreasing. That's no. Both have to be the same. Like increasing means left increasing, right also increasing. Left increasing, right also decreasing. That way we will be able to make a merging. Okay. Makes this merging process work. Okay. Fine. Now I'll just come to the logic. Let us pick main variable, first variable I, and just first of all pointing 0 in the index. Okay, 0 index of left array, and let me take another variable j points to 0 the index of right array, and that is one array called as merged, right? Because it is equal to size of this merged array is equal to 11 by because first left array right array is having select elements. Plus because I'm going to merge both of them means element both the array will be completely there. So 5 plus 2 will have 11 elements. So that's why I've taken a merge of 11. And I'll be taking a variable called as k, which is pointing to 0 index of that by default. Now what we do is I make comparison between what? Between the left array index and the right array index. So between these two values, we will make a comparison based on that we will do the process. So when I take left right j, I will just think which one is minimum, whether left I is minimum, right j is minimum. Suppose that left I is minimum, left I is less than right j. Suppose left I is minimum, then I will pick left I element and I will place it in merged array at eighth index. If right j is minimum, then I will pick right j element and I will just take it and I will place it in merged array at eighth index. So at that point, at every point of time, whatever is the minimum element between ith index and ith index of left and jth index of right, that minimum element will be taken and it will be taken to a merged array. Okay. So now looking here, left of I minus left of 0, because presently I is 0, left of 0, 10. Right of j is also 0. So right of 0 is 7. So we are making a comparison between 10 and 7. So which one is minimum, either 7 or 10? 7 is minimum. So whichever is the minimum value, we need to pick the minimum value and replace the kth index of merge. As a present kth index 0, you take the 7 and replace it in 0, and once you place the value, first task that you need to do is increment your k by 1. Now your k will be reaching 1 index. And either two things, either you could have picked the left of I, or otherwise you could have picked the right of j. So if you are picking left of I, you should increment your I by 1. Suppose if you are clicking your right of j, then you have to be incrementing your j by 1. I think you have clicked the right of j. So now j should be incremented by 1. So j will, from 0 it will go to 1. Because already 0 is the next value you have taken into account. So no need of still pointing to it. That's why we are incrementing j by 1. Now again, same process. Check the present left of right upward. I here 0. So left of 0 10. But j has become 1, whereas right of 1 is equal to 16. So when you make a comparison between 10 and 16, one is minimum. 10 is minimum. So let me pick the 10 and let me place it in the present kth. So 10 will place a present in like kth index. So this is pretty clear. Listen. Because this is like process operation as well as the merge sort is completely automata or let it be automata fix. Let it be any company like CCS, or CCS, or Infosys, whatever the company. But this has been a very common question in all the streams of like company recruitment, campus recruitment. So be very strong in like what I'm just telling you. This is definitely this will help you. Okay. Now presently I'm just comparing the present I index value, j index value. I found that I index value which is 0 value 10 is the minimum. I pick that minimum. Place the j index of merge. Once you place a value in merge array, then the respective k value will be incremented. K becomes 2. But did I pick the left of I, right of I? I did the left of I. So which means I shall be incremented by 1, where my I will be reaching 1 index. Comparison between I index and j index. So I index means 1 index of left is 15, 1 index of right is 16. So 15, 16, this one is minimum, 15 is minimum. Which means left of I is minimum. So take left of I, 15, place it in merged, increment k value by 1, so k becomes 3. Okay, and then increment also I by 1 because you have picked the left of I. So increment I by I is equal to 2 now. Again, make a comparison between ith index of left and right, ith index of right. So ith index of left is ith index of ith index of left is 26. J index of right is 16. So when I make a comparison between 16 and 26. 16 is minimum. So I take that 16 and I place it in kth index. So kth index I will take 16 and I place it here. And after placing element in the first process I need to increment k by 1. So k will be incremented by 1. K will become 4. And which element between jth index element right because we have to be incrementing j by 1. So my j will now become j will reach second index. Now let me compare the ith index of left second index 26 and same second index of right is 33. 26, 33, 26 is minimum. Let me take and place k index of merge and let me increment my k by 1 where my k will be reaching fifth index. Okay. And also after clicking 20 which is ith index value, then I should increment that by I by 1 and I will be now pointing to third index of left. Now j pointing to second index. So ith index value was 31, j index value is 30. Comparing 31 is lesser. Take 31 and replace with k index of merged array, and then increment k by 1. K will reach 6. Then increment I by 1 because you have to the left of 5. So I have to increment my I by 1 and I will be reaching 4 index 45. take the present ith index value of 45 and take the present jth index value which is 33, second index. Which one is minimum? 33 is minimum. Take the 33 and place it in k index of merged array and implement k by 1, so k will reach 7, and implement your j by 1 because you have built the right of j, so increment increment your like j by 1, j will reach third index. Now compare fourth index value 45 and fourth index third index value 38. Which one is minimum? Third index, jth index 38 is actually minimum. So let me take that 38 in place jth index, and then let me increment k by 1, so where k is equal to 8. And also you have to jth index element, you have to also increment j by 1, so not I have to increment my j by 1, where my j will be reaching fourth index. Now compare ith index 45 and jth index 46. I think ith index 45 is minimum. Let take the precedent. Present kth index of merge, and then let me increment the k by 1. And I pick the ith index, so let me increment I by 1. My I will reach outside. Go outside the array. When it reaches outside, what we can see is all the elements of the array has been already taken. When all the elements of the array is taken, when one of the array is completing, the next array, the other array will definitely starting one element. Both the arrays will not become empty at the same time because it is either becoming left of I or otherwise it is either becoming right of I. So when you are picking only one element from one of the array, then both cannot become empty at the same point of time. Either one will become empty first and then the next will become empty. So whichever array is becoming empty, whichever array completely all the elements are taken, you just put the next array, the other array, and whatever the remaining elements of which has not been taken, copy all those elements and transfer it to merged array. So where was the jth index? It is in fourth index. So copy fourth index and fifth index and transfer it to the remaining index of merged. So take your jth index value 46 and place it in the present kth index of merged array and increment k by 1 where k will reach 10 and k will reach 10. And increment like j by 1, jth index by 1 where this increment your jth index by 1 where j will reach 5. Okay, where j will reach 5. And now you take jth index value which is 48 and place it in kth index of merge which is jth index is 48. So take 48 and place it in merged array. Next, after placing this, k will have to be incremented by 1, so k will be incremented by 1. And j also have to be incremented by 1. So after you look at this, j is also outside the array, k is also outside the array. So when j is also outside the array, we can say, okay, now both the array elements, all the elements have been taken. Now you look at the merged array, completely everything is sorted out as 7, 10, 15, 16, 26, 21, 30, 38, 45, 46, 48, and all the elements including left and right array, every single element is also available in the merged array. So this is a concept of merging where you take two sorted arrays and you merge both of them and you convert it into a resultant array called as merged where all the elements of left and right array will be available. That everything is in sorted order. So this is what merging process is all about. Is everybody clear with the merging process? Is everybody clear with the merging process? Any clarification with the merging process first of all? What will happen if both array has the same element? You pick anyone. Just make this condition left of less than or equal to right object. So both are equal also, you just start picking left. You make something common. Either if it is equal, pick some random, like left up, right up, whatever. Is not going to make any change. Okay. So both the elements you're picking is left up, right up, both are equal. You can pick any element. So make the condition as left up, left or equal to right up. So then I will take left up, like equal to also I will take left up. Let me make like that. Okay. If it's descending, what you will do? For descending, same way we will do only one different changes. Left up by less than right up, we will not check. Left up by greater than right up, check. Left up by greater than right up, check. I will pick left up. So whenever you are combining left up and right up, which one is greater, that you pick and take it to merge. That's it. Here you are picking the minimum element, you are taking to merge. That is. There you will be picking the greater element, and you will be taking it to merge. That is. That's the difference. What happens if two arrays are not in sorted order? And merging process is not possible. When two arrays we have taken is not in sorted order, it is not following the property, so it cannot be solved with the help of, it cannot be merged with the help of merging. So this cannot be used to solve for. How will we know that the arrays are in sorted order? Okay. How do we know if it is in sorted order? Means suppose you know very well that it is in sorted order, you opt out. Or otherwise, you create a function is sorted. You have to create, you have to write a different logic where is sorted will check when an array is given, it will check whether the array is in sorted order or not. How to check whether a given array is sorted or not? Everybody knows bubble sort, am I right? In bubble sort, what is the technique? You take every adjacent element and you compare the left side element is greater, lesser, and right side is greater. Suppose if the left side is greater and right side element is lesser, we will make a swap, am I right? So similarly, if G sorted, what we need to do is we will take every adjacent element like 0, 1, 1, 1, 2, 2, 3, 3, 4. When I take 0, 1, 1, I need to check whether 0th index is lesser, 1th index is greater. 1 and 2, 1th index is lesser. So, whichever element, param element I pick, left side should be lesser, right side should be greater. If that is true for every adjacent element, then I can say the array is in sorted order. If not, then I have to say that the array is not in sorted order. So we have to create a separate function called as eSorted to check whether the given array is sorted or not. This technique, if you know very well about the arrays, you have all the information about the arrays, then you can go with that. If you want to detect it, then you just create a eSorted function which will be checking whether the given array is sorted or not, and then you proceed. So students, this is clear for everyone? Okay. Hope it is clear for everybody, right? Fine. Now what I will do is I will take the same logic. Okay, I'll just take the same logic and I will teach you now how to merge sort this with the help of this particular operation. Okay, so let me take one more example of unsorted array which we will take and we will convert it into sorted with the help of merge sort. Okay, let me teach you that. Okay. Now I've taken an array. First, 1, 2, 6. Better what I will do is 1, 2, 3, 4, 5, 7 is just 1 minute. 1, 2, 3, 4, 5, 6, 7, and 8. So there is a total of like 8 elements. Okay, there is a total of 8 elements. So let me take the index also 0, 1, 2, 3, 4, 5, 6, and 7. Now let me only pick elements. All the elements exactly. Let me pick. So 21, 10, 45. Okay, and I'll go with 15, and then comes like 7, 25, 12, 13, 9. So these are the elements completely in zigzag manner, like unsorted. Merge sort is a divide and conquer based strategy. Okay, divide and conquer. What is divide and conquer? Divide and conquer is a strategy where like we will take a problem, we will divide it into sub problems, okay, and we will divide the process. We will divide the given problem into sub problem. We will divide into sub problem where the sub problem further cannot be even divided. So we will just divide it into smaller sub problem, okay, very smaller sub problem, and we will solve every smaller sub problems. Okay, we will solve every smaller sub problem, and we will take the answer of every smaller sub problem, and we will we will by using the answers of every sub problem together, we will create a answer for the given problem. So basically, divide and conquer is a problem is provided, we divide the problem into sub problem, we conquer every problem, we solve every problem, and we take the answer of all the sub problems together to find the answer of the entire array. Okay, now entire problem first of all. So first what I will do is I'll try to split this problem. I'm going to try to divide the problem into sub problem. For that, first of all, I will just take 0th index to be your starting index and last ending index. So 0th index is starting, 7th index is my ending index according to this array. I try to find my midpoint. What is my midpoint? How to find my midpoint? Take your starting index, ending index, add both of them, divided by 2. So starting index is 0, ending index is 7. And if I add both of them, I get 0 plus 7, 7. Then 7 divided by 2. Okay, 7 divided by 2 will be equal to 3.5 exactly, but we will round it off to 3 and we will take 3. So now 3 will be, third index will be midpoint. Okay, this third index is going to be the midpoint. Okay, so after I found my midpoint, what I need to do is from starting to midpoint, I should divide it separately. From mid plus 1 to end, I should separately divide it. So the same array will be divided into two different parts. Whereas in one part, I have this complete array 1, 2, 3, 4. Whereas we have 21, 10, 45, and then 15 we have. And here it is going to be 0, 1, 2, 3 index corresponding. And starting from m plus 1 to e, okay, that is end. Starting from m plus 1 to end, there is going to be a total of 4 boxes, where it is going to be 4, 5, 6, and then 7. 4, 5, 6, 7. And coming to 4, 5, 6, 7, it is going to be 7, 25, 12, and then 39. So we have taken the original array and we have just split it into two equal parts. Okay, now let us pick these parts, and this also will be divided further. Okay, until a subproblem can't be divided further, until that particular situation, I'll keep on dividing it. So here, if you, for this left side array, if you take separately, S and E is there, starting index and ending index. When I take the starting index and ending index, I have to find mid index, which is starting index is 0, ending index is 3. Add both of them, 0 plus 3 divided by 2, which is 3 divided by 2 is equal to 1.5. 1.5 is rounded off to 1. So 1th index is going to be the midpoint. So starting to midpoint one side, I will be splitting. From mid plus 1 to end, I will be splitting on the other side. So starting to mid means only 2 elements, which is 21 and 10. From mid plus 1 to end is also 2 elements. So here it is going to be 21 and 10 on one side, and 45 and 15 on other side. So this is 0th index, 1th index, and here it is 2nd and then 3rd index. Similarly, I need to do the same splitting here for this also. Here starting index is 4, ending index is 7. So what will be mid index? 4 plus 7, 11 divided by 2, exactly 5.5, but we round it off to 5 and we take. So here the midpoint is 5th index. So starting to mid index, it is going to be one, like one part. So whereas 7 and then 25 will be taken, whereas index is 4th index and 5th index respectively. And on the right side, we will be taking an array of 2 elements, which is 12 and then 39, and it is 6 and then 7. Okay, now again I can divide it. So I take these two arrays and I divide it into 2. So here starting point is 0, ending point is 1. What will be midpoint? Midpoint is starting plus end. 0 plus 1 divided by 2. 0 plus 1 divided by 2 means 1 divided by 2, 0.5, but we have to round it off to 0. So midpoint is also 0. So starting to midpoint means 0 to 0, only 0th index element will be taken on one side. Mid plus 1, 0 plus 1, 1 to end point 1. So 1 comma 1. So which means 1th index will be taken as a separate. So 21, 0th index, here 10, 1th index. Similar, everything will be split into single element, individual element. So 45 will become an individual element. 15 will become an individual element, and the respective indexes, 2nd index and then 3rd index here. Then here the 7 and 25 will be split into 2 parts, where one side it will become 7, the other side it will become 25, and this is index 4 and this is index 5. And here also 12, 39. This also is split into 2 separate parts, where one side we will have 12, the other side we will have like 39, respective index 6 and 7. Now hereafter I will not be able to divide it further, because I have taken 8, split it into 4, 4, then 4 elements is taken and split it into 2, 2, and 2 elements are split into 1, 1. Hereafter 1 element will not be able to split. That's the finest, smallest part of the array. So that's it. The splitting, divide process is over. Division. So in divide and conquer, divide process is over. You have taken an array, you have taken a problem of array of size 8, you have divided into smaller sub-problems, and finally you have the smallest sub-problem. Now I need to start conquering. Like I need to find the answer. I have to, from bottom to top, I need to reach. For dividing from top to bottom, we have come. Now I have to solve from bottom and I need to reach top again. By finding the answer of every sub-problem, we have to take it all together and we need to reach the topmost part. Now what I'm going to do is, I'm going to take these 2 parts and I'm going to merge it together. Merging process that we said, right? Okay, so for merging, what is the constraint? The 2 arrays that we are taking have to be in sorted order, right? 21 is the single element array. 10 is a single element array. When 2 single element arrays is there, can I call it a sorted? We have 2 single element array. So 21 is a separate array, 10 is in a separate array. So when 2 single element array is available, can I call both this array to be sorted? Can I call 21 is sorted, 10 is sorted, 45 is sorted, 15 is sorted, 7 is sorted, 25 is sorted, 12 is sorted, 39 is sorted. Can I say that? Can I say every individual element as a sorted array? 21 is separately sorted, 10 is individually sorted. Can I say like this? So there are 2 sorted arrays. 21 is a separately sorted array, 10 is a separately sorted array. Can I perform merging operation between both of them now? Can I just perform merge operation? Because it is following the constraint, right? Both the array we are picking is in sorted order. So if we perform merging operation between both of them, what will happen? You will find a array of size 2. You will find an array of size 2 which is completely sorted. So if I merge both of this together, this particular array will become sorted. When I merge 21 and 10, this particular array becomes sorted, where it will become 10 and 21. Because as a result of merging, we will take both the elements together, we will combine it, and also the resultant array also will be in sorted order. So this array will become sorted. So when I take this 45 and 15 and merge, this array will become sorted. 15 and 45 it will be. 15 and 45. So you consider that this is left array, this is right array, and this is merged array. Okay,
When left array and right array is merged together, what will become? Merged array will become sorted. So this is already sorted. Okay, when you merge also, you will get the same result, 725. The same thing that you apply for this last. Okay, left array 12, right array 39. When you merge both of them is already in sorted order, so no changes will be taking place. Now you come one step above. Now this array is also sorted, which is this is sorted and this is also sorted, because we have merged these two things to make it sorted. And we merged these two arrays and to make this particular array sorted. So now both of this array have become sorted. So when you take two sorted array, you can merge it, right? So when you merge these two sorted arrays, what will happen? This is now left array, this is right array, and this is the merged array. So now when I merge both left and right, what will happen? Merged array should become completely sorted, which means what I will do, I will check 10 and 15, which is minimum. Minimum is 10. I will take the 10 and I will place it in first index. Then after 10 and 15 is compared, 10 is minimum. So 10 is gone. Now I will take 21 and 15 and I will compare. Which one is minimum? 15 is minimum. So the next index of this array should have 15. Then 15 is gone. Remaining is 21 and 45. So 21, 45, which one is minimum? 21 is minimum. So let us take 21 in place. So after I take 21, left array becomes empty. So right array still, like 45 is available. Let us copy that 45 to the this array. So now when you merge these two arrays, what happened automatically? These four elements have become sorted. Same thing, when you merge these two arrays, what will happen? This will completely, it will become sorted, where it will become 10, 12, 7, 12, 25, 7, 12, 25, and then 39. Now you have two, like arrays of size 4. Okay, you have two arrays of size 4. If you merge both of them together, okay, you have two arrays of size 4. Now when you merge both of them together, what will happen? This array, this resultant original array, it will completely become sorted, because this is now we are considering it to be merged array. So what will happen? We will compare 10 and 7. Okay, for example, I will take I is equal to 0 and j is equal to 4. When I just combine both this thing, jth index, which is 7, will be the minimum value. So I pick that 7 here and I will just simply place it here. Then I will pick 10. Okay, then the minimum element is 12. So next index we will have 12. And the next minimum value is 15. That comes in third index. The next minimum value will be 21. That comes next. And the next minimum value is 25. And the next minimum value is going to be 39 and 45 it will be. So 39 comes. And after 39, then 45 comes. That's it. The original array could have become sorted. So first process is divide, and after dividing, every pair of splitting that we had, right? Every pair have to be merged. Once you merge it, automatically the parent. Okay. So if you're merging two child element, the parent element will become completely sorted. By doing this from bottom to top, finally the original array also will become sorted. This is a process of merge sort. So is it everybody clear with the process of merge sorting? First of all, is it everybody clear with the process of merge sort? Fine. So now what we will do is we'll just go for the implementation of this. Implementation is where, like, okay. So the implementation is where, like we need to spend a little bit of time. So let us just get into the implementation. Okay. Let me share you the code editor, and after this implementation, let us just get into the next topic. Okay. Okay, fine. So we will just start with the implementation of merge sorting. Okay, so fine. So coming here, let me just start with hash include stdio.h, then integer main function. Okay, fine. So first of all, inside main function, first thing that we will do is we will just declare a variable called as n. And let me use scanf to receive it. So scanf %d, comma ampersand n, semicolon. And then after that, let me take an integer array ARR of size n, and let me run a loop for integer I equal to 0, I less than n, then I plus plus. So inside this particular loop, let me go with scanf %d, comma ampersand ARR of I. So what we have done here, first we have received how much element is going to be given for sorting, and we have declared an array of that particular size. We have received all those n elements, and we have stored in like all the indices of ARR. Now we are going to write two functions. One function is going to be like void merge is the process, and that is one function. Second function is also going to be void, and the function name is going to be merge sort. So one is merge sort, the other one is merge. Okay, so now for merge sort, see, merge sort, this is going to do the process of divide. Okay, divide and conquer. It is going to do this division process. And merge, this is the merging process we first of all saw, right? So merging process it will be doing merging of two sorted arrays. Okay, even in yesterday also I think we just discussed this. So merging of two arrays. So divide, so merge sort will be like it will be performing divide, and in merge we will be doing merging process. Okay, fine. So now coming inside this divide, okay, coming inside, so merge sort of okay, now coming to divide, first thing I require, what is the parameters that is required is, first thing I require the input array ARR. Second, I need to know what is the starting index, and next I need to know what is the ending index. That's it. These are the three parameters required. First step, what I will do is, before starting anything, I will declare a variable called as mid, and I will try to find the mid index by having starting and ending. So starting plus end divided by 2 will give you the mid index. That's it. Very, very simple. So start index plus end index divided by 2 will give you mid index. Now what we need to check is, I need to check whether if start is less than end. Okay, if start is less than end, then if start is equal to end, I can't do anything. That's a starting point, right? Start and end when both are equal means both are equal, only one single element is available. When only single element is available, we will not be able to split it further. So if only the starting index and ending index, starting index is lesser, ending index is greater, then I can go for splitting process. So what is the first, splitting that I have to do? Left side splitting, right? And moreover, if you look at that entire tree structure, like the merging, splitting tree structure, it is a recursive form. We are also going to do recursion only. For the left side one, we will give one recursive call, and for the right side one, we are going to give a separate recursive call. For left side one, what can be the recursive call? Merge sort of, merge sort of same ARR, comma, where what will be the left side part actually, starting from starting index to mid index. We have found, right? Starting to mid index, it is left side part, mid plus 1 to end, it is right side part. So ARR, comma, starting index, comma, mid, it is going to be one part. So for that, I'm just making a recursive call. And after making that left side splitting, the next recursive call is for right side splitting, where I call merge sort function. I pass ARR first parameter, second parameter start. So from mid plus 1 to end point. Okay, mid plus 1 to end point. So from starting to midpoint, it is one left side array, and from mid plus 1 to end, it is going to be right side. So two recursive calls for two splitting, left side and right side splitting. Both the left side splitting and right side splitting, when both is over, when both the left side is splitting and the right side splitting, when both is over, okay, merge sort of ARR, comma, start, comma, mid, and merge sort of ARR, comma, mid plus 1, comma, end. When both the left and right side is, we have got, okay, both the right side splitting and left side side splitting we have got, then we need to merge both of them. So after this two things, I will be calling the function merge, and I'll be passing ARR as the first parameter, the respective start index, the present mid index, and the present end index. All these things I will send it as a parameter. So now the merging process will start. So for merging, what we should have taken, first thing, we should have taken the entire array. Then the second one, we should receive the starting index. Then we should receive mid index, and then we should receive index. Because by receiving these three values only, we know from start to end, mid it is left side array, and from mid plus 1 to end, it is right side. That we will be able to understand. So now coming inside this merge, we are going to take array into mid index. We will be taking from plus 1 to end. We will copy all the elements to two different array, and then we will be merging it out. Okay, we will be merging it, merge the single array. Okay. So now the question is, from start to mid, how many elements will be available? Okay, len 1. How many elements will be available between start to mid? I think I would say mid minus start plus 1. Like for example, I will just tell you, from second index to 10th index, how many elements will be available? 9 elements will be available, which means you take the last index, end index, subtract it to the starting index, and also add 1. Because 10 minus 2 is equal to 8. But actually speaking, inclusive, if you are including, there will be totally 9 elements. 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 elements will be there. So you should take point subtracted by starting, and then that should be added with, it should be added with 1. Okay, so from mid minus start, that means between start and mid index. What about from mid plus 1 to end? From mid plus 1 is the starting point. Remember, starting point is mid plus 1, ending point is END. Now, how many elements will be there? END minus of. Remember, END minus of mid plus 1. So, ending and starting index subtracted, then finally one should be added. So, when I add this, what happens is this minus, when it is subtracted inside this bracket, it becomes minus mid and minus 1 and then plus 1. So, this minus 1 plus 1 is cancelled, and it will be end minus mid. So, you can say that from mid plus 1 to end, there is going to be end minus mid. Len 2 is equal to end minus mid number of end minus mid number of values will be available. Okay, end minus mid number of values will be available. So I've taken like mid minus start plus 1 elements will be available in like the left side array, and end minus mid number of element will be available in the right side array. So let me pick two arrays. First of all, I'll just pick two arrays, which is left array, which is going to be of size len1, and also I will pick an array called as right, which is going to be of size len2. I've taken two arrays of len1 and len2 respectively, where len1 is from start to mid how many number is available, and then len2 is equal to from mid plus 1 to end how many. So left side array, right side array typically it means. Let me copy all the elements from start to mid index to left, and all the elements from mid plus 1 to end to right. So let me take a variable called as k and initialize it with 0, and let me run a loop starting with with start index and less than or equal to mid index I plus plus, and let me pick all the elements of ARR in ith index. Let me pick that element and let me place it in left of k plus plus. It means, okay, in the left of first 0th index element, I will take like start index element and I will place it. Then start plus 1 in 1th index, then start plus 2 in second index, and keeps on going. Similar kind of loop, same loop should be repeated for the right array for copying all elements from mid plus 1 to end. Again, I start k from 0, but only difference is here I value have to be starting. It should be started from mid plus 1, and I will be less than or equal to end. It will be less than or equal to end. In this process here, left of k, not left of k plus plus, it is going to be right of k plus. So right of k plus is equal to AR of that. Now all elements from starting index to mid index is copied to left array, and from mid plus 1 to end all the elements are copied to right side array. Now we need to merge both left and right because they are both definitely will be in sorted order. We need to merge left and right. So for merging process, first of all, what I will do, I will take I equal to 0, j equal to 0, where I 0 pointing to left array, 0th index value, and j index refers to right. Friends, is it now audible for everybody? There is a network disconnect actually. Is it now everybody is able to clearly hear my voice? Okay. And now my voice should be clear. So now I'll just explain this again because fine. See, students, I'll just explain this again because like in between, I think my voice should have been like fluctuating because of network issue. So let me like explain like the things again. I explain whatever is in the screen again. Okay, fine. So now what we will like do is. Okay, so now coming here to the code. First thing is, if you see here in the main function, we started by declaring a variable n, and we received the value of n from user. We declared an array of size n, and then we received n element from user, and then we wrote two functions. One is merge sort, and one is merge. Merge sort function is actually for doing the operation of dividing the problems, right? So first of all, for that, I require the array and the starting index, the ending index have to be passed as a parameter. By taking these three arguments, first of all, we need the midpoint of the entire array that we are picking now. Whichever array we are picking, we need to find the midpoint. Then I will check whether also start is less than end. Okay. So because if start is equal to end means we have reached the end. Start is equal, when the start will be equal to end, start and end will be same for only individual element. When we are splitting only individual element. So when we have got the individual element, there is no further splitting should be done. Only for start less than end, I will have to go with for start less than end. I need to first of all go with splitting. We split two things. Left is array. What we did, the midpoint we got from start to midpoint. We shift but in the first records it's happening. Same ARR I'm picking, but from start to mid I'm taking, which means my end point has become mid, which means from start to midpoint I've taken it as a separate part, and from mid plus one to end I've taken it as a right part. So this recursive call will split the original array from start to mid, it will take a separate part, and the next merge sort it will take it to the right side part. From mid plus one to end it will split it into the right side array. And after I got both left array and the right array, now I need to merge both the array. Left array as well as the right array, I need to merge both of them. So I will merge both of them by using this merge function. For this merge function, I'm passing a array start mid end all this parameter and this sending. Okay, I'm just sending all this array, then start index as a parameter. Is it still my voice is breaking? Tell me in the chat box, is it still my voice is breaking? So students, is it clear now? Is my voice is clear now? Do everybody is able to hear me? Is it? Am I audible now clearly? I've changed my network. I think people said that it was just trucking. Is yes. Okay, fine. Let me continue. I'll just explain this, and then I will also take the recursive calls, everything, recursions, everything. I'll show you in the stack also. Okay, fine. So let me continue, students. No, like I think my voice, there is a small network issue. So now, when I just look at here in this code editor, see what we are doing in the main function. We just was simply receiving how many elements is given and what is the size of the like if n element is available, then the size of the array have to be ARR of n. So we have taken an array of size n, then we receive n element from user, and then we have received all the n element from user and we have stored it in the array ARR. And now we wrote two functions, merge sort and merge, where merge sort we are using for divide. So how we will divide? Any array if you take, we divide into two equal part, left array, right array, we divide. So for left array, this first recursive call, where from start to midpoint, we are finding also the midpoint of the entire array. From start to midpoint, we are taking it to the left side, and from mid plus 1 to right end, we are taking it to the right side. And after we found both the left side array and the right side array, we now merge left array and right array. And for that merging process, I have taken this merge, and I have passed array starting index, mid index, end index. Now coming here to this merge, I have array ARR. I have starting point, midpoint, end point is there. So which means from starting to midpoint of ARR, it is left side array. From mid plus 1 to end of the ARR, it is right side array. So first of all, I just found how many element is there available between start to end. There is total mid minus start plus 1. I just come up with a formula, mid minus start plus 1. That many number of element will be available from start to mid. Okay, for example, if I want to find how many elements is available between 4 to 10, how many elements? 7 elements will be available. But when you take 10 and subtract it with 4, it will give you only 6, but actually 7 elements. That's why extra 1 we will be adding. So end minus start plus 1. So that's what I'm doing here. Yeah, here the endpoint itself is mid. So mid minus start plus 1 elements that I'm taking. Similarly, for the from mid plus 1 to end, okay, from mid plus 1 to end, there will be a total of end minus mid number of elements. So I have taken end minus mid. So for that length 1 number of time, I have taken array left, and length 2 number of time, I have taken array right. And I copied all the elements from start to mid index to left side array. And I copied all the elements from mid plus 1 to end to right array. Now we're going to merge together. Already the merging process technique we know. We have to take I equal to 0 for left side array, j equal to 0 for right side array, and k is going to point to the merged array. Here the merged array is the input array ARR itself. Whatever element that we are merging, let us take it and let us replace the original array itself. Which part we will be overwriting from start to end, because that is the part we are merging, right? So whatever element that we are getting, we need to take it and we have to place it between the start to end index. So I'm just starting my k equal to start. K is pointing to original array, that is merged array. Okay. So now what is that we need to do? First of all is I need to check whether if left of I is less than right of I, right of j. Suppose if left of I is less than or equal to, I will say, okay, if it is less than or equal to right of j, I need to take that left of I and I should place it in ARR of k. So ARR of k plus plus is equal to left of I plus plus. Left of I plus plus. So incrementing k by 1, incrementing I by 1, both happens in the same line itself. We don't want to repeat it. Suppose if this condition is not true, means right of j will be the minimum value. So then ARR of k plus plus is equal to right of j plus plus. Okay, ARR of k plus plus is equal to right of j plus plus. And this should happen either if both the arrays having some element available. So I will just take this and first of all write it inside a loop because it is going to be a repeated process. The same process have to be repeated for many I and j values. So I will also check whether that I is less than len1, and at the same time I will check whether j is less than len2. So if both this condition is true, means then what, like at least both the arrays having some element. So we will be able to take ith index, jth index and compare. If any I or j, any one thing becomes like completely filled, suppose if I completely filled or j is completely filled, what happens? We need to take the other one and we need to copy the elements. Okay, so how we will be finding that? After coming out of the loop, I will check whether while still I is less than len1, I will check, because if one array becomes empty, other array will be definitely not empty. Okay, so I less than len1, I will check. Suppose if I is less than len1 only, this will be working. So that point of time, I will go to ARR of k plus plus and I'll take this like left of I plus plus directly I will be taking. So once I becomes equal to len1, we will stop. And the same loop I will be taking for j also, because that also might have some element. So while j less than len2, I will check. Suppose if that condition is true, we will enter inside ARR of k plus plus is equal to right of j plus plus, right of j plus plus. Okay, right of j plus plus. Okay, so now this while is over here, this while, and here this while is over. Okay, right? So now it's completely done. Okay, complete merging process is done. Okay, so now when we look at after this main function here, if you just simply call this merge sort of ARR, comma, starting point is 0, ending point will be total number of element minus 1 will be the last index n minus 1. When this merge sort function is called, now definitely ARR could have become sorted. Now let me iterate over the entire, because array, if we pass, always array will be passed by address. So whatever changes which is happening over there will be reflected everywhere. So integer I is equal to 0, I less than n, and then I plus plus. So now, sorry, loop I less than n and then I plus plus, and coming inside, let me go for print and percentage d space comma and ARR of I, semicolon. Okay, let me save this. So GCC -o hello, and this is going to be merge sort.c, no syntax error, hello, and let me give for example 10 elements, 10, 23, 76, 5, 20, 32, 45, 16, so 1, 2, 3, 4, 5, 6, 7 elements, still 3 more elements, 53, 61, and one more element is 98. So 10, 23, 76, 5, 32, 45, 16, 53, 61, and 98. So totally 10 elements. So now after that, if you look 5, 10, 16, 23, 20, 23, 32, 45, 53, 61, 76, 98, completely it becomes sorted. So which means this is working properly. So merge sort, this is for divide and this is for merging two set of arrays. That's it. Okay, so have a look at all these things. So first of all, I'll show you the process of merge. Okay, so you say when I need to scroll down. Okay, I'll just scroll down. Okay, fine. See, students, wait, I'll just also send this code also. Just give me a minute. I'll just send you the code also as well as. Students, have you received the document? I have sent you a document. Have you just received it? On the other side, have you received it? Yes. So now look into the code and tell me if you have any clarification. Okay. So check the code. Okay. Check the code and tell me if there is any clarification, any particular line. If you have any clarification is required, post the line number and the clarification that is required, and I'll explain that to you. Okay. Yes. I'll just the common question is, how do you come with this mid minus start plus one and n minus mid? How does this formula came? Actually, see, about this formula, how we took this mid minus one, this formula is, say set for example, right? If your starting point is equal to 2 and if your ending point is equal to 8, how many elements will be between these two indices? 2, 3, 4, 5, 6, 7, 8. 6 elements. Oh, sorry. 7 elements will be there, right? 2, 3, 4, 5, 6, 7, 8. 7 elements will be there between 2 and 8. If you also include 2 and also 8 is included, 7 elements will be there. But when you take your n and just subtract it by start, okay, 8 minus 2 means 6 only you get, but extra 1 element is also included. So for that, we will just simply add 1. So here, I wanted to know how many elements is between start and mid, how many elements is from start to mid. So mid is the final point here. So I take mid and then I subtracted start, and extra 1 element I have to be adding. So that's what example I show you. That's why I have taken mid minus 1, mid minus start plus 1. Now coming here, next to 1, I want to know how many elements is between mid plus 1 to end. So from mid plus 1 to end, if you want to know, you take end and then subtract it with mid plus 1, and also you need to add 1 to the formula, right? Now when you take this minus and multiply inside this one, so it will become minus mid, and minus 1 it will become. Okay, end minus mid minus 1, then plus 1. So minus 1 plus 1, it will cancel and it will become end minus mid. And it will become end minus mid. So that's why we have taken n minus mid as a len2 value first of all. So this is one thing that we need to get clarified. Okay. So any other clarifications that you want apart from this, please? Okay, there is one question. Each divided array is not sorted, no sir. Then how we are sorting that individual? See, like suppose, like, I don't know whether, like everybody is actually, like Tamil or Telugu, like even any Telugu people is there inside. I don't know. So because most of the, like whether everybody is okay with Tamil, like also. Anybody is there without knowing Tamil? Can you just tell me in the chat box? Is it everybody knows Tamil, or is there anybody in the crowd without knowing Tamil is there? Chat box. Anybody, if you don't know Tamil, just tell me in the chat box. If you know, it's absolutely okay. Okay, fine. Okay, better, like, okay, fine. I'll just come to it. Okay, so when you just look at here, like one question that I just saw was, each divided array is not sorted, no sir. Then how we are sorting that individual L divide? I think in the diagram I showed you that I just showed you a diagram where the given array is divided, right? Where we are starting our merging process. We are starting our merging process from the bottom layer. Bottom means when individual element is available. Left side 1 element only is there. Right side 1 element is only there. So left side only 1 element is there means, can I call that array to be sorted? On the right side only 1 element will be there. 1 element, single element means we need to call it sorted. Okay, no other way, no other go. So I start my sorting, I start my merging process from 1 element, which is in sorting order only. So when I take 1 element, like array of one size 1 and array of another array of size 1, when I merge, what will happen? The arrays with size 2 will all be merged. When I take array of size 1 and I'm merging, array of size 2 all will be sorted, become sorted. Then when I take array of size 2 and when I merge, automatically array of size 4 will get sorted. Then after array of 4 getting sorted, then I will take array of size 4 and I will merge automatically. Array of size 8 is getting merged. Sorted. So initially everything is not sorted, but because of I'm taking, like a single length element, I'm merging it together, they are becoming sorted. When I take 2 single element array and merge, a 2 element array becomes sorted. When I take 2-element array and when I'm merging 4-element array, automatically becomes sorted. When I take 4-element array and I'm merging, automatically 8-element array becomes sorted. So that's how we are doing it. Okay. Right. I think, like everybody would be clear with this. So fine. What we will do is okay, fine. So what we will do is we will just go and take up a break and come back. After the break, we will again continue with the further topics. Okay, I'll just tell you, we are going to learn about binary heap. After the break, we will start with binary heap, a data structure called as binary heap, which would also be required for Automata as well as Automata Fix, because using binary heap, we will also learn a sorting algorithm called as heap sort. So automatically that would be helpful for Automata Fix as well as for Automata. It will be a very big topic. Okay, fine. So go and take your break and then come back. Let us, start with a new topic. Okay, yeah. Relax yourself and come back.